Hi everyone, welcome to day 3 of Unit 3. Today we're going to talk about continuous functions. Now we kind of started talking about this in class a little bit, and if you have any questions, please write them down like on the side. We will definitely go into more detail about this next class. Okay? Let's start with our vocab. Continuous functions are graphs that contain an infinite number of ordered pairs, and these graphs tend to make lines and curves and stuff like that. Important notes about finding domain and range for continuous functions. Because we have an infinite number of points, we can't list them. So we actually have to resort to using inequalities. And when we do inequalities, we're basically telling whoever is reading our answer that all the x's are within this range, within these numbers. So we give them a starting point, an ending point, and everything in between. So to find the domain, we look for the edges of the function on the x-axis, and to find the range, we look for the edges of the function on the y-axis. That will give us like the highest and the lowest it can be, and then we talk about everything in between. Now if you hit an arrow, so with these kind of graphs, they have a lot of arrows on the ends because we can't draw the entire thing because it can go on forever. So we just put an arrow to show that it goes on forever. So when we see an arrow on the edge, it means that we're actually going to either positive infinity or negative infinity, depending on where, like which way the arrow is pointing. So just keep that in mind. Now there's two different notations we can use. Set builder, which is the standard that we have to learn, and then interval notation is the honors version. So set builder, we just write it as a compound inequality. So what we do is we do the smallest number and then less than or equal to the variable, another inequality sign, and then the biggest number. That's how we're writing it every single time. Only with less thans, we just go. Okay? And actually you can ignore the second blank. You don't have it on yours actually, just ignore it on mine. So we use a less than or equal to if there's an actual point on the value. So if there's an actual point on the smallest number, will be equal to it. We'll have an equal to part. If it's an actual point on the biggest number, we'll put an equal to for that inequality. Now if it's going to infinity, like we hit an arrow on the edge, we're just going to put less than. Okay? For interval notation, I think it's even easier because all we have to do is write the smallest and the biggest number, the comma in between, and then we use either parentheses or brackets to tell if it's equal to or not. So we will use a parenthesis around the number if it is not equal to, meaning it goes up to that number but not equal to, and we'll use a bracket if it is equal to. Okay? For infinities, we're always going to use parentheses because we can't actually be infinity, we can go to infinity, not be. Okay? Example 1, find the domain and range of the function and write your answer in set builder notation. We're actually going to do it in set builder and interval. So for the domain, I'm going to make it smaller so I can use these things. The domain is this axis right here. So I'm looking to where it's hitting there. So one edge of my graph for the line is going to this number, and one edge is going here. Okay, I just like to highlight, kind of badly, but I do. Now, on this side, I'm hitting an arrow, so that means it's going to continue to go out to negative infinity. So that's my smallest, is negative infinity. And I actually like to write it on the side. So this is going to negative infinity. Don't make fun of my infinities. While this guy, I hit a point when I did it, so that's where it stops. So it stops at 1, 2, 3, 4. Okay? Those are my numbers I'm going to use for set builder notation. Negative infinity is my smallest, 4 is my biggest. Now, with infinities, I'm going to use less than, a less than symbol. But with the 4, because I actually have a point that uses the x value of 4, I'm going to have a less than or equal to. So my set builder notation looks like this. Negative infinity is my smallest. It is less than, not equal to, x, which is less than or equal to 4, because I actually have a point on 4. So now for my range, I'm going to do the same thing. I'm just going to use a different color. Highlighter. The highest y value is here. Right here. and the lowest y value is right here. Okay? So I'm just going to write out what those numbers are in a pan. So my highest y value was actually at 2, because it was over here. And my lowest one was at 1, 2, 3, 4, 5, -5. That is my range. So we are between -5 and 2. Those are all the y values getting used. So for my set builder notation, I would say y such that the smallest number is -5. This should be an equal to, which of course it's not. It should have an equal to, because I actually have a point on -5. And then I have a point on 2, so it should also have an equal to part. Now for set builder, I'm using these same or not for set builder. For interval, I'm going to use the same numbers. But I'm just going to write the numbers and then put brackets or parentheses around it. So for the domain, I had an infinity, which I can't equal, so it's going to get a parenthesis. And then a 4, which I did equal because I had a point there, it's going to have a bracket. So my domain looks like this. I'm going from -infinity to 4. I can't equal infinity, but I can equal 4. The range is going from -5 to 2, and I have points on both -5 and 2, so that means I'm going to have brackets around both. Okay? So now you guys are going to try this one on your own. Okay? I strongly advise using colors to help you and writing stuff on the graph, but you don't have to. Okay? So give this one a try. Notice that you have 2 arrows here, so be aware of that. We're going to go ahead and move on to example 2. So we're going to find the domain and range of this function, write your answer in interval, and we're going to do set builder as well. We kind of already did this in class a little bit. So I'm going to go ahead and I'm going to do my edges. So I'm just going to do set builder first. So for my x's, I go from here, which is at -5, and to here, which is at 3. So I'm just going to write those down. I got -5 here, and I got a 3 here. So -5 is equal to or less than, so I should have that inequality. I actually have a point there, so less than or equal to x, which is less than or equal to, because I have a point there, 3. So my domain looks like this. My range, I'm just going to use a different color, goes from down here to here. And that's as far as it goes. Okay? And then my numbers, just so I can know what numbers I'm using. So I have -1 down here, and I have 7 up here. So my set builder will look like this. Y such that -1 is less than or equal to, because I actually have a point on -1. Y, which is less than or equal to, because I have a point there, on 7. Okay? And then for domain and range for interval notation, I just take those numbers. For the domain, it goes from -5 to 3, and I have brackets around both of them because I actually equal both of them. Range goes from -1 to 7. I have brackets around both because it equals both. So now you guys are going to try this one on your own. Careful of the arrows. And we will go over those try on your owns next class. Okay? If you have any questions, please write them down. I know this can be a little confusing. Hopefully we dealt with any confusion during class, but just write them down. I'll see you guys next time. Bye.